All right, so we are discussing Lewis structures for molecular compounds, right? We're in part 4, I believe, of bonding. And last time we got into the beginning of Lewis structures, and we said these were Lewis structures for molecules, right? And molecules imply what? I am sharing electrons, that this is a covalent bond. And we said there's a list of rules, and we said, hey, rule 1 was what? We want to count one, two, no, count. We want to count what? The number of valence electrons in the compound, right? And so we use our periodic table to determine that. And then 2, we want to choose a central atom. And we had some hints on choosing a central atom. We said, hey, quite often it is carbon, it is never hydrogen. We might get a hint by looking at the formula. See the formula. Quite often the formula tells us how things are bonded. And quite often it is the least electronegative atom, right? But these are all hints. These are little tips for helping us. Oh, we also said sometimes we choose it based on symmetry, if it makes it symmetric. Good. Then we said after that, we've got our electrons, we've chosen our central atom, we bond all atoms to the central atom, all atoms to central atom, and then we complete octets. Complete octets, right? And we're going to leave some space here because we're going to have to write some exceptions now here. So we complete octets, and then number 5, we said we want to compare electrons in picture with number of valence electrons. If they're equal, then we're done. And we say Yahoo, and we draw a little funny face, happy face. Yay! Wow. He's got a smile halfway up his face. Well, that's okay. It looks like an egghead there. Good. So let us move forward. And here we go. Consider the molecules methane and ammonia. Draw the Lewis structures for these molecules. Here we go. Let's start off with methane. We can do this. First of all, we want to figure out the number of valence electrons. How many valence electrons do we have? Well, we look at carbon, and what does carbon say? I look at carbon. Where's carbon? Here's carbon. There are 4 valence electrons for carbon. Hydrogen has 1. Okay, so we know 4 and 1. Good. So we have 4 for carbon, plus 4 times 1 for my hydrogen, and that looks like 4 times 4, 8. Good. And then I'm going to choose a central atom. I have carbon. All right, I'm going to put carbon as my central atom. I am going to bond my hydrogens. And then usually we'd do what? We'd say complete the octets. Well, we have an exception here. Let's go back to our notes. Complete octets, except. Except. We see this all the time in chemistry, the word except. Except. Here's exception number 1. Hydrogen, helium, and lithium only take 2 electrons, not 8. We don't complete an octet. These guys take 2. And yeah, you guys can remember some of this, right? Because we were talking about exceptions to the octet rule. Well, that's what we're talking about here. Beryllium wants how many? Beryllium doesn't want 8. Beryllium will take 4 electrons, not 8. And C, boron, usually takes not 8, but will take, boron takes, we got to make takes, boron takes 6 electrons, okay? So we complete the octet, that means 8 electrons, right? With the exception of these 1, 2, 3, 4, 5 for the time being. There's another exception coming. But hydrogen is the big one. We use hydrogen a lot, and we don't make 8. We don't put 8 on it. We only put 2 on it. So each of these lines means what? Each line really means, hey, I've got 2 electrons, right? So how many electrons does this hydrogen see? It sees 2. So this hydrogen has 2. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. So each of my hydrogens has 2. My carbon has what? 2, 4, 6, 8. Wow, I think everybody's cool. Okay, let's rewrite that in a prettier way. There we go. Meow. That's the Lewis structure for methane. Okay, let's do the next one. This is ammonia. Are you ready? Ammonia. We have NH3. We know each hydrogen has 1 valence electron. And what about my nitrogen? Go back to my periodic table. Periodic table. Nitrogen is here. How many valence electrons? 5. Okay. So let's go back down to our picture. We're going to nitrogen. Nitrogen has 5 valence electrons. So what do we have? 5 plus 3 times 1. 8 valence electrons. Good. So let's follow the rules. Which of these do you think will be my central atom? Hydrogen or nitrogen? Well, nitrogen, because hydrogen never is. Let's bond my hydrogens to it. Good. All right, and let's see. Each of my hydrogens has 2. How many electrons does my nitrogen have? Well, it's got 2, 4, 6. Does it have its octet? No. So what do we have to do? Add 2 more electrons. And now, you know what I forgot to do last time is count, right? We need to count these all. Here we go. I'm going to use the red pen. 2, 4, 6, 8. I have 8 electrons in my picture. How many valence electrons did I have? 8. So that means we are done. So draw this in a nicer form. Looks something like this, right? There we go. There's my Lewis structure for ammonia. All right, you guys do water. Pause me and bring me back when you are done. Water. Okay. How many valence electrons from hydrogen? 1 each. How many for oxygen? 6. So I have 6 plus 2 times 1, and that means I have 8 valence electrons. Good. What's going to be my central atom? Not hydrogen, so I'm going to put oxygen in the center. We're going to bond our hydrogen to it. And then we want to complete our octets, except for hydrogen only wants 2. This hydrogen already has 2. This hydrogen already has 2. Remember, why do we say it has 2? Because this line means what? That line means there are 2 electrons, right? So this hydrogen indeed sees 2 electrons. How many electrons does my oxygen have right now? Well, 2, 4. So what do I have to do? 6, 8. All right, let's add them all up. Use the red pen. 2, 4, 6, 8. So there are 8 electrons in my picture. How many did we need to put in our picture? 8. There we go. So let's make this a nice pretty picture. Yoink, yoink. Oh, that's, sometimes I make my electrons look like lines instead of dots. There we go. That is water. Beautiful. Going farther. Oops, too far. There we go. Next. Ooh, I like that yellow. Pretty. Consider the molecule CO. Okay. Draw the Lewis structure. Where do we start? Valence electrons. Carbon has 4. Oxygen has 6. Good. Choose a central atom. Well, we only have 2 atoms, so either one's central. So we'll go like this, right? Cool. Now what's the next thing? We want to, oh, 4 and 6 is equal what? 10 valence electrons. Good. So we need to have 10 valence electrons in our picture. Now what do we do? Okay, we complete the octets. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. This looks like a piece of cake. And so we're done, right? No, we have to count them up, right? So how many electrons do we have in our picture? 2, 4, 6, 8, 10, 12, 14. So I have 14 electrons in my picture. And how many am I allowed to put in my picture? 10. Ay, caramba, we have a problem. So what do we do here? Well, let's go back to our rules. Where are our rules? Here are our rules. We need to add something else. Compare number of electrons and pick. Okay, if there are too many electrons in your Lewis diagram, what does too many mean? More than the number of valence electrons, right? That's what too many means. Then what do we have to do? Then start over. Oh my gosh, yes. Start over and use double or triple bonds to connect atoms. Okay. Remember I said, hey, you might want to use pencil when you do this stuff because you will have to erase, and indeed you will have to erase. Here we go. So what did I say? Start over. So I'm going to go carbon, oxygen, but we said don't use a single bond, use double and triple. So let's try a double bond here. Yoink, yoink. Okay, now a double bond means what? A double bond means that there are now 4 electrons being shared here, right? So when I complete the octet, how many electrons do I have to add to oxygen? Well, it already has 4, so 5, 6, 7, 8. Carbon, 5, 6, 7, 8. Good. Now let's add them up. 2, 4, 6, 8, 10, 12. So now I have 12 electrons in my picture. Is that good enough? No, I only have 10 valence electrons for us to use. So what do we have to do? Start all over. Carbon, oxygen, and then this time what are we going to do? Not a double bond, but a triple bond. And that triple bond means what? That triple bond means there are 6 electrons being shared. So to complete my octet, how many electrons do I need on my oxygen? 2 over here. How many on my carbon? 2 over here. Now, my carbon would see how many electrons? 2, 4, 6, 8. So that carbon sees 8. And this oxygen would see what? 2, 4, 6, 8. Good. Now let's count them up with my red pen. 2, 4, 6, 8, 10. So I have 10 electrons in my picture. How many am I allowed? I had 10 valence electrons. It looks the same to me. That means this is a wiener, yeah? Good, a wiener. And let's redraw this to make it look nice and pretty. It would be what? C, triple bond, O, couple electrons over there. Oops, sorry, that's not that. That looks like an I on my carbon. Yank. There we go. How's that? Is that better? Perfect. So that is my carbon monoxide. Great. All right, you guys try HCN. All right. Pause me, and when you're done, bring me back. Well, the first place we begin is count valence electrons. 1 for hydrogen, 4 for carbon, and 5 for nitrogen, right? Good. So that's 9, 10 valence electrons. Let's choose my central atom. I'm going to choose carbon for a couple reasons. So number 1, it's carbon, and it's usually central, but they also, notice how they wrote it, HCN, and by writing it this way, they're implying that C is in the middle. So I'm going to go C, and I'm going to put N over here. I'm going to put H here. I'm going to bond these two guys. Now what do we want to do? Complete the octets. Well, in hydrogen's case, it's fine because it only wants 2. Carbon has right now 2, 4, so 5, 6, 7, 8. Nitrogen has 2, 3, 4, 5, 6, 7, 8. Good. And now let's count 2, 4, 6, 8, 10, 12, 14 electrons in my picture. Yikes, that doesn't work. What do we have to do? Start all over. Erase. Carbon in the middle. Nitrogen. Hydrogen. Double bond. Now, here's the interesting thing. Can I ever double bond hydrogen? Well, if I double bond hydrogen, it means I have what? 4 electrons here. Does hydrogen ever take 4 electrons? 9. It does not. Hydrogen only takes 2 electrons, so we never have a double bond on hydrogen. Yoink. So my hydrogen is single bonded, which means where's my double bond? Between my nitrogen and carbon. Now, let's complete my octets. Nitrogen, 2, 4, 5, 6, 7, 8. Carbon, 2, 4, 6, 7, 8. Let's count up my electrons. 2, 4, 6, 8, 10, 12. 12 electrons. Compared to 10, nope, doesn't work. What do we have to do? Start all over. Yipes. You got to be kidding me, Mr. Smith. Do I really have to do all this over and over? Yes, this is chemistry. And this time, instead of a double bond, we're going to go triple bond. We do things over and over until we get them right, right? And let's complete our octets. Good. My hydrogen here has 2 electrons. My carbon has what? 2, 4, 6, 8. And my nitrogen has 2, 4, 6, 8. Everyone has their required number of electrons. Let's count up the total. 2, 4, 6, 8, 10. So I have 10 electrons in my picture. How many am I allowed? 10. Yeehaw! And so this would be the correct Lewis structure for hydrogen cyanide. How many of you got that right? Excellent. Going farther. All right, farther, farther, farther. Okay, well, it looks like we only have 2 more to go, and then we'll call timeout here. Selenium tetrabromide. Okay, we know how to do these things, right? Selenium tetrabromide. Let's go up here and let's look at our periodic table. Bromine. Here's bromine. How many valence electron? 7. Selenium. How many valence electrons? 6. Okay, 7 and 6. Going down elevator. Good. 7 and 6. So we have 7 here and 6 there. And I have 4 of these guys. So 4 times 7 is 28. Plus 6 is 34 valence electrons have to be in my picture, right? Well, what are we going to choose as our central atom? Selenium, because that would make things nice and symmetric. Not only that, selenium has a lower electronegativity. Let's bond my bromines to them. Okay, good. Now what? Complete our octets. Yoink, 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 oink, 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 moo. Good. Now count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, piece of cake, 32, and that matches exactly. Oh, no, it doesn't. We've got 34, and we have only 32 electrons in our picture. What do we do now? Well, let's go back to our rules, and let's look at number 5 here. It says compare electrons to number in the picture. And we talked about if there are too many electrons in our picture. What if there are too few electrons in our Lewis diagram? What do we do then? Very simple. Add excess electrons on central atom. So if I don't have enough electrons in my picture, I have more valence electrons, then what do? I just put them on my central atom. That's easy enough. Okay, here we go. So Here I have 34 electrons. Here I have 32. That means I have 2 electrons too many, and too many valence electrons. Not too many, but not pictured in my Lewis structure. So what do I do with these two? I place them on my central atom anywhere. So we'll put them right here. Good. So now that would make this 34, 34. And so this is my Lewis structure. Let's clean this up. I have selenium, and I'm going to draw it slightly differently here. Let's see. I'm going to kind of say, let's put bromine here, and let's put a bromine here. And let's put a bromine here. And you don't have to do it this way. I just do it kind of for fun. Oops. I really need to do it this way. Sorry. Put a bromine here. You'll see later why I did it this way. But you don't have to. When we get to molecular geometry, you'll say, oh, now I know why Mr. Smith did it that way. Okay, good. So let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. And so that is our beautiful Lewis structure for selenium tetrabromide. And here you go. You do this one, and then we are done for this lecture. Bring me back to life when you are ready for the answer. Okay, valence electrons. Bromine has 7. Fluorine has 7. There are 5 of those. So 5 times 7 is 35, and 7 looks to me like we need to have 42 electrons, valence electrons in our picture. What am I going to use as my central atom? I'm going to use bromine. I'm going to put 5 fluorines around it. How about 1, 2, 3, 4, 5. We want to complete octets. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Bromine already has what? 2, 4, 6, 8, 10. So bromine already has more than 8. Let's count these up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. I have 40 electrons in my picture, and I have 42 I need to show in my picture, which means what? I have a deficit of 2 electrons, and where do I place those 2 electrons? Somewhere on my central atom. There we go. And so to make this look nice and pretty, there we go. And that would be my bromine tetrafluoride. And we are done for this lecture. One more lecture on bonding next time, and then we're done. Okay, thanks. See ya. And so it goes.